Hello everyone, welcome to my YouTube channel. So today we are going to solve NCERT solved examples of a 1D motion in a straight line. Right? In the previous videos, we have already solved all the PYQs of a 1D motion in a straight line. And now today we are going to solve all the solved examples from the NCERT book. Right? And you are able to understand all this concept, I think. And we started to solve all the solved examples. Right? So this is our first question. Rain is falling vertically with the speed of 35 meter per second. So rain is falling vertically. Just one minute. Rain is falling vertically with a 35 meter per second. And with the speed of 35. And wind starts blowing after some time with the speed of 12 meter per second from east to west. East to west direction means this is our east, this is our west. So wind is blowing from east to west direction. Let me write this. Velocity of rain is 35 meter per second. Velocity of wind is basically 12 meter per second. East to west direction. In which direction should a boy waiting at a bus stop hold his umbrella? So first we find the resultant of these two, and the resultant is comes out to be in this direction. Sorry, just 1 minute. The resultant is comes out to be in this direction, right? So this resultant is here, and you know this angle with the vertical is theta, and you know this is our, when we apply this Pythagoras, this is parallel vector. So you can also write this is velocity of water, that is same, that is 12 meter per second. So let me I draw this diagram here so that you can understand in a more better way. Velocity of water, that is 12 meter per second. Here velocity of rain, that is 35 meter per second, and this angle is theta. The resultant of these two comes out in this direction, and we can find by Pythagoras theorem. You know this Pythagoras theorem, so we directly apply Pythagoras theorem. 12 square plus 35 square, so that comes out to be, just 1 minute, 12 square is 144 and 35 square is basically 1225. So our resultant is comes out to be 144 plus 1225. You add it, and then after that you square root. So this comes out to be 37 meter per second. 37 meter per second. And then after that, what to do? They're asking direction. So for direction, you find angle, that is tan theta. Tan theta is equal to perpendicular velocity of water divided by velocity of perpendicular upon base. Velocity of perpendicular upon base. So velocity of water is here 12. Velocity of rain is 35. If you divide this 12 divided by 35, so this comes out to be 0.34. And if you find the angle of it, theta is equal to tan inverse 0.34. So this comes out to be 18 degree, roughly 18.9 degree. So what is the meaning of it? Just let me show. I show this how the things is going to explain you. Like this is our rain is falling vertically. It is like this situation. The rain is falling vertically downwards like this, and wind is blowing in this direction. So their resultant is comes out to be in this direction. So the resultant is comes out to be in this direction, and their angle is theta. So opposite to it, we have to hold is our umbrella. Opposite to it, we have to hold our umbrella. That this angle is theta. So this angle is also theta. If the rain is coming in this direction, so we have to put our umbrella vertically opposite direction of the resultant velocity, right? And this angle is 18.9 degree. Understand now? You are getting my point? So I proceed for our next question. This is our just 1 minute example. Okay, I got this example. Just 1 minute. I put it. So this is our example 2. In this question, what they're telling that find the magnitude and the direction of the resultant of two vectors A and B in terms of their magnitude and angle theta between them. So it is like they are asking the derivation. So let I show this derivation. I don't have issue. This is our one vector. This is our one vector. This is our another vector. Okay. This vector I gave the name. This is P vector. This is our Q vector. And their angle is theta. And if the resultant of these two vector comes out like this is our resultant vector and they are making angle alpha. So by using parallel vectors, we have to find the resultant of it. So what I do, I shift the parallel vectors like this. This vector is also like this. And what about this vector? Like this. And what about this vector? Like this. Just 1 minute. I expand this vector. This angle is alpha. So by parallel vectors theorem, this is q vector, so this is also q vector. And this angle is theta. This is p vector, so this is p vector. If I resolve this vector, so this comes out to be q cos theta. Here, q sin theta. So I able to show this by resultant vector. You know the resultant of two vectors. You can find by Pythagoras theorem. By Pythagoras theorem, this is I say O, A, B, C, D. Right? I show this by this resultant of it. That this angle is alpha and this total length is P plus Q cos theta and this length is Q sin theta. So by applying Pythagoras theorem, we can find this thing. Let us solve this so that you get the better idea of it. P plus Q cos theta whole square plus Q sin theta whole square. So if I solve this, this is applying A plus P whole square identity. This is P square plus Q square cos square theta plus 2PQ cos theta plus Q square sin square theta. So resultant of it is coming out to be P square plus, this is, if you see this, if I take Q square common, so sin square theta plus cos square theta is become 1 and left is 2PQ cos theta. You're getting my point? This angle is theta. So resultant of it is coming out to be P square plus P square plus 2PQ cos theta. And the direction we can find by finding the angle. So tan alpha, can I apply tan alpha is equal to Q perpendicular Q cos Q sin theta upon P plus Q cos theta. So final conclusion, what I wanted to tell you, this you can remember, this whole derivation is not required, but important thing is you understand this concept. This angle is, and another question, the resultant is just a minute. R vector. This is our P vector, this is our Q vector, and this is our resultant vector. So you see this P vector and Q vector angle is theta, right? And our resultant vector and P vector angle is alpha. And also remember this also, you can get that Q vector and R vector angle is beta. So if I find tan alpha, I can also find tan beta also. Tan beta, how we can find? Just we have to replace P by Q and Q by P. So I directly got tan beta is equal to P sine theta. Just a minute. P sine theta. P sine theta Q plus P cos theta. Just a minute. This comes out to be another answer. So these I think you can remember these two results is enough for us. Getting my point? And now we are going to solve our next question. And these results are very important in the next upcoming question. We directly use these results, right? So I proceed for our next question. This question is also very important. A motor boat is racing towards north at 25 km per hour and water current in that region is 10 km per hour in the direction of 60 degree east of south. Find the resultant velocity of the boat. Motor boat, just first make our diagram. First thing, we make the diagram. It is become easier for to understand this. This is, and there is also this. This is our east. This is our west. This is our north. This is our south. A motor boat is racing towards north at 25 km per hour. Motor boat is racing towards north at a speed of 25 km per hour. And water current in that region is 10 km per hour in the direction of east of south. Means this is our east of south. And this angle is 60 degree. And this is velocity of water. That is 10 km per hour. So you know this is 60 degree. So definitely this angle is how much? This angle is how much? Let us show with a different color so that you can recall it easily. This angle is 120 degree. Right? So they are asking find the resultant velocity. So we can just apply directly resultant vector velocity formula. Velocity of board square plus velocity of water square plus 2 times velocity of board, velocity of water, cos theta. And you know that velocity of boat is 25 km per hour, velocity of water 10 km per hour. And then after that, you can also apply one more thing. I think just 1 minute, one more thing. This angle between these two vectors is 120 degree. So you can directly substitute these values. So here velocity of boat is 25 square plus 10 square plus 2 times 25 into 10 into cos 120 degree. So velocity of resultant is comes out to be comes out to be 25 into 25, that is comes out to be 620. 25 into 25, that comes out to be 625 plus 100 plus 250, 50 into 10, 500 cos 120. Cos 120 means cos 90 plus 30. Cos 90 plus 30. Cos 90 plus 30 minus sin 30. Minus sin 30 means minus 1 by 2. So velocity of resultant is comes out to be, let I show this. So this is 725 minus 250. So that comes out to be 725 minus 250. This comes out to be resultant is comes out to be 475. And if you take the root of it, this comes out to be 21.79 kilometer per hour. Getting my point? Understand now? Not any doubt. Because we have directly find this formula, resultant vector formula. Now we can directly apply this formula. Now I proceed for our next question. This is also a very good question. The position of a particle is given by this. They have given the position of the particle r is equal to 3t I cap plus 2t square j cap plus 5 k cap. The t is in second and the coefficient have the proper units r is in meter. Then velocity of vector means we have to just differentiate with respect to time. So if I differentiate with respect to time, so this comes out to be 3 I cap plus 4t j cap. So here velocity with respect to time is comes out to be 3 I cap plus 4t j cap, and acceleration vector with respect to time is d square r upon dt square. So again we differentiate. So this comes out to be 0. 3 I cap, if I do differentiation, so this comes out to be 0. And if I do differentiation of 4t j cap, so this comes out to be 4 j cap. So here acceleration with respect to time is comes out to be 4 j cap. Right. Now our next task, we have find velocity, find velocity with respect to time and acceleration as a function of time of the particle. Then after that, this is our first A part, and then after that B part, find the magnitude and direction of velocity. B part, find the magnitude and direction of velocity at time t is equal to 0. Means velocity as a function of time t we are finding at 1 second. This comes out to be 3 I cap plus 4t. 4t is 1 j cap. So this comes out to be 3 I cap plus 4 j cap. If I find the magnitude of it, so this comes out to be 9 plus 16. So this comes out to be 25 under root. And if I find the magnitude of this velocity, so this comes out to be 5 meter per second. 5 meter per second. Then after that, find the direction. So we have to find the direction. So direction, how we find tan theta is equal to y component of velocity upon x component of velocity at t is equal to 1 second. So y component of velocity is 4. X component of velocity is 3. So tan theta is equal to 4 by 3. So this comes out to be just 1 minute. It gives the idea tan theta means this we assume like this is our hypotenuse. So this is our biggest section. If this is 3, this is 4. So this is our 37 degree. This is our 53 degree. And this is our 90 degree. So here see 4 by 3. Perpendicular. This is tan theta is perpendicular upon base. So perpendicular upon base means this is theta is equal to 53 degree. Getting my point? Let's proceed for our next question. This is our question number 5th. Okay. And in this question, what they are saying, a particle starts from the origin. Means their initial speed is 0 at t is equal to 1 second. With the velocity, particle starts from the origin. Origin means their initial coordinate is 0. With the velocity of, means they have given x component velocity, that is 5 meter per second, and moves in x by plane under a action of a force which produces a constant acceleration 3 I cap. So x component of acceleration is 3 meter per second square. Y component of acceleration 2 meter per second square. What is the y component of the particle at that instant? Its x coordinate is 84 meter. And what is the speed of the particle at that time? They are asking y coordinate of the particle at that instant where x coordinate is 84 meter. So first we apply equation of motion as is equal to x direction, we are applying ux t plus half ax t square. So x coordinate is 84, that is ux 5t plus half acceleration in x direction 3 t square. So this comes out to be 84 5t plus 1.5 t square. So this is comes out to be quadratic equation, t square 1.5 t, just a minute. So 1.5 t square plus 5t minus 84 is equal to 0. So here t, if you find now, if you solve this quadratic equation, so let me solve this. Minus 5 plus minus under root b square is 25 minus 4. A is 3 by 2. A c is minus 84 divided by minus b plus minus under root b square minus 4ac upon 2a is 3 by 2. So here t comes out to be minus 5 plus minus, then minus minus plus, this become 2. So 2 3 are 6, 6 into 84. So this comes out to be 25 plus 504, and here comes out to be 3. Okay. And then after that, if you find the under root of this, this comes out to be 25 minus 5 plus minus 23 divided by 3. So t comes out to be, here if you take minus sign, so minus time is never be negative. So if I take positive, so minus 5 plus 43 by 3. So here t comes out to be 18 divided by 3. So this comes out to be 6 seconds. T comes out to be 6 seconds. Now we can directly find x coordinate. So we have to find x coordinate. First, now easily we can find x coordinate. X coordinate we have to find, right? So x coordinate we can easily find. X is equal to ux. We have to find, sorry, y coordinate. Y coordinate we have to find. So y is equal to u by t plus half a by t square. So y is equal to u by t is 0 because initial direction in y direction there is no velocity. Half acceleration in y direction is how much? 2, and t is also 6 square. So 2 so 2 cancel. So y comes out to be 36 meter. Right. So this comes out to be 36 meter. Now what they're asking, speed, what is the speed of the particle at that time? The speed of the particle at that time they are asking. Right. So speed, just a minute, we can apply Ex is equal to ux plus ax into t in x direction. So x direction, initial velocity in x direction is 5 plus 3 into t is 6. So velocity in x direction is 18 plus 5, 23 meter per second. And in y direction, u by t plus half a by t. So vy is equal to y direction velocity is 0. Acceleration in y direction is how much? 2. T is 6. So velocity in y direction is 12 meter per second. So velocity you can find that comes out to be vx square plus vy square. So that comes out to be, so that is comes out to be 23 square plus 12 square. You know 23 square is how much? 5, 29, and 12 square is 144. And their square root if you find, so this comes out, this is 673. And if I find the magnitude of it, this comes out to be 25.94 meter per second. Understand? So we have find A and B both part easily. Right. Now I proceed for our next question. This is about Galileo in his book. Two new sciences stated that for the elevation which exceeds or falls short of 45 degree by equal amounts, the ranges are same. So this is standard result. Range is equal to u square sine 2 theta by g. You know this thing ki if I take this as just 1 minute, 45 degree minus alpha or 45 degree plus alpha, or otherwise there are also 90 minus theta or 90 minus theta. These three condition ranges remains same. Why? Because if you see that sine 2 45 degree minus alpha, if you do, so this comes out to be sine 90 minus 2 alpha, and this is cos 2 alpha. This also you see sine 2 45 degree plus alpha, so this again sine 90 degree plus 2 alpha, so this is again comes out to be cos 2 alpha. You see that both components are coming same at 45 degree, 45 minus alpha and 45 plus alpha, and theta or 90 minus theta. So we can say that why ranges are same for these angles, right? Ranges are same for 45 degree minus theta, 45 degree plus theta, and theta or 90 minus theta. Understand? Now I proceed for a next question. A hiker stands on the edge of a cliff 490 meters above the ground and throws a stone horizontally with the velocity of 15 meters per second. Neglecting air resistance, find the time taken by the stone to reach the ground and the time with which it hits the ground. So this is like this. A hiker stands on a 490 meter height, right, and above the ground, and throws a stone horizontally. Means they throws the stone horizontally with an initial speed of 15 meter per second. Neglecting air resistance means they are giving the velocity in x direction is 15 meter per second. Initial velocity in y direction is 0. Acceleration in x direction is 0. Acceleration in y direction is minus g. So what they're telling, the time taken by the stone to reach the ground and the speed with which it hits the ground, right? So first it asks we apply equation of motion in x direction. Sx is equal to uxt plus half ax t square, half ax t square. So in x direction, you know this is 490, and then after x direction there is no velocity. Acceleration, sorry, there is a velocity in x direction. Sorry, this is velocity in x direction 15 t and acceleration in x direction is 0. From here we get that time, how much time they take to reach the ground. 490 divided by 15. So I got how much time they take to reach the ground is, that is 32.67 seconds they take to reach the ground. Now our next task, at what velocity it hits the ground. So velocity we have to find, right? So how we can find velocity at which it hits the ground? We have to find velocity in x direction and velocity in y direction. So Vx is equal to ux plus ax into t. So Vx is equal to 15, acceleration in x direction. So actually velocity in x direction remains constant. Our next task, velocity find in y direction. U by t plus a by t. So velocity in y direction there is no velocity. Acceleration in y direction is 10, time is 32.67. So this comes out to be 32.67 into 10. So this comes out to be 326.7 meter per second. So now we have to find the magnitude of this velocity. So what I do, just find the x component and y component. This is 15 square plus 326.7 whole square. So this comes out to be, let me just I do this, 326.7. If I do squaring of it, 106,732.89, and 15 square is 225. So if I find this is 6,732.89 plus 225, so this square root is comes out to be 327 meter per second roughly around, right? Is it fine? So I think this is enough for us. In the next video I solved other NCERT solved example and their exercise problem. But I hope these videos are quite helpful and you are enjoying my videos. And if you have any doubts regarding in my videos, you can ask and join my Telegram channel. And please share with your other friends who are preparing for Neet and JEE examination. I wanted you to best in this Neet examination and get the good ranks. And I hope you are doing very well preparation and you are do as much as possible. And if you have any doubt regarding that, you can ask me or you can also join Telegram channel, and please like and subscribe my YouTube channel so that I get the more motivation to make more videos and more content which is relevant for you, which is very useful for you in your preparation. Thank you so much.